does academic accuracy matter if you have practical proof and application. And what I mean by this is, in academia, there's a lot of pedantic definitions that really are important for creating theories and figuring out how stuff works. But it doesn't necessarily translate into practical application, so like making use of it. I'll give you a few examples. So in physics, there's a common misconception of what an accelerator does. So most people think an accelerator makes you go faster, because that's what it does in a car. But in reality, in a car, you have 3 accelerators. You have the gas pedal, the brake, and the steering wheel. Because by definition, acceleration is any change in velocity. Velocity is speed with a specific direction. So if you do anything to change speed or direction, you are accelerating, you're changing velocity. And that creates a force. So imagine this theoretical idea, right? You're blindfolded in the back of a van. If someone stomps on the brake, you get flung forwards, right? If someone stomps on the accelerator, you get flung backwards. If someone turns the steering wheel hard, you get flung to the side. Now, if you couldn't hear the van and you didn't know what driving patterns were usually like, you wouldn't be able to tell which is which, because they all generate a force that feels the same because you're accelerating. But that being said, like when you think, there's another one where when you go round a roundabout, people call that the centrifugal force, and that's technically inaccurate. It's the centripetal force which causes the centrifugal effect. But does that change a motorcyclist's ability to lean the bike to cause a centrifugal effect to be able to do a tight turn? No. Just because they don't know the theory behind it, they can still do it. And I think this is really well demonstrated by, when you look in academia, professors at university who study economics, business, finance. These guys and girls are the top of the top in academia in these subjects, and they know the most out of anybody, but yet they're not the wealthiest. Why is that? I thought they were the best. Because practical application has different set of circumstances. It's not just academic theories, right? And so what got us thinking about this today was Millie and I were just meeting up with some friends. We were playing a game of werewolves. It's like Mafia or Traitors. I'm sure you've heard of it, many other games. But essentially, there are 2 werewolves, and we're playing with a group of 8 people, and we both got chosen, and we were thinking, well, what are the odds of that actually happening? Now, this is a really simple GCSE maths question, if you model it as such. So if there are 2 werewolves out of 8 people, and I take a card at random, I've got a 2 in 8 chance, or a 1 in 4, right? If Millie then goes after me, there are now only 7 cards to choose from, and only one of them is a werewolf. So her odds are now 1 in 7. So to calculate our total odds, it would be my 1 in 4, 1 divided by 4, times her 1 over 7, which gives us 1 in 28, which sounds about right. But the reality of how the cards are dealt is someone had a card before me. So I actually only had out of 7 cards to pick from. Then I took my card, and then 3 more cards were served out, and then Millie took her card. Now, why doesn't those cards that are served out change the probability and the likelihood of the card that I pick when I'm now picking from a smaller pool? And I think it's because I don't know. Now, I'm like 96 to 98% confident in my answer on this, so if you have an opinion, I would love to know what you think, as if I'm right here. But the theory here gets a bit murky, but in practical application, like, it doesn't really matter. And we could figure it out experimentally. So we could just do, like, you could deal this out like 500 times, and about 20 of those, you'd expect you and your partner to both be the werewolves. And if that happened, great. And I think this is where it comes to practical application of business, is you can talk about theories about how things work and all this sort of stuff, but until you've been in it, until you've really lived it, you're missing this bit of context that theory can't provide you, that you have to get stuck in. And so my strongest piece of advice is, if you're trying to learn a new skill, is dive in the deep end, get the first 20 hours out of the way, be willing to look like a fool, put your hand up, ask stupid questions, because it will teach you more than spending a year reading a book ever will. So yeah, those are my thoughts on this interesting idea between academic knowledge and hypothesizing versus practical application and experience. And there's definitely a link between the two, of one can help the other. Like, the more knowledgeable you are about a topic, the faster you're going to learn about it because you understand how things work. But if you never practice, there's things that you will never understand because you haven't experienced them. And so I think it's a really key to go in prepared, but also be willing to dive head first and feel it and experience it for yourself. Yeah, those are my thoughts for the day. Have a great evening, guys, and comment below if you've got an answer to my basic GCSE maths question. Peace.